file system analysis that we're going to be doing next? Or was it registry? Do we want to do registry first, right? After process, you do registry, right? Yeah. Because that's like Windows Registry, right? Let's do that one first. Registry analysis. By the end of this module, students will be able to navigate and understand the Windows registry structure, identify malicious registries, modifications, and artifacts, apply forensic techniques for registry analysis, correlate registry evidence with other system artifacts, implement detection rules for registry-based threats, document registry-based incidents for incident response. So that is it for the learning objectives. For the fundamentals, right? What is the Windows Registry? The Windows Registry is a hierarchical database that stores low-level settings for the operating system and applications. It serves as a central repository for system configuration data, hardware and software settings, user preferences, individual user customizations, application settings, program configuration data, security policies, access controls and permissions, system state information, current operational parameters. And this is sort of how it will look. With the registry structure, you'll have your HKey classes root for file associations and COM objects. You don't have to really know this, but it's good to at least know how these attacks work, right? Registry data types, type description, common usage. We have these strings, string value pass, and we have these reg multi SZ multiple strings list of items. And we have a reg expand, expandable string with environmental variables. We have reg dword 32-bit number flags. Settings is reg keyword 64-bit. Number large numeric values, reg binary, binary data, raw data. And then we have certificates. Critical registry locations for threat detection. And these are how the persistent mechanisms store themselves in these startup locations. HKLM software, Microsoft Windows version run. They can store themselves in the run once, the run once, and the current version run. So these are the registry paths that these startup locations, they'll hide their malware so that it can start up in these startup locations, right? Service registration, we have, this is another place that attackers will hide their malware, right? If it's for Windows malware, they'll start their executable, right? The image path, they'll do the type of start, they'll probably do auto start, right? And then they'll be like type of service, file system. Then they'll just do probably file system driver because it could just launch as an executable, right? Or they'll do service. Or I mean, they could do kernel if it's a kernel level malware, right? Logon scripts, they have, this is how they would log on, right? User initialization program, shell default shell program, and notification packages. They would probably turn those notifications off, right? So that they wouldn't be getting like those Windows Defender notifications, stuff like that. Or they just turn Windows Defender off. Scheduled tasks, they'll hide stuff in the scheduled task so that at a later date their malware will run. At the system modification locations, Windows Defender exclusions, they have these exclusions that'll exclude their program from that Windows Defender. So the attackers will do this to hide their malware, right? Network configuration, they'll want to be set up on one of your good network interfaces that is receiving internet, right? So that they can use their command and control server to access your PC. Security settings, they will use the security settings so they can downgrade, right? Well, that's what I would think, because they're trying to downgrade your versions and your policies and stuff like that, so you're not using any of like that stuff that'll prevent their malware. Common malware registry tactics, run key abuse, legitimate entry. They'll take a legitimate entry and just insert their program in that legitimate entry, right? They'll put their malicious file in there, right? So that it looks like it's kind of like supposed to be there. Detection indicators, executable in unusual locations, temp or public folders, suspicious process names mimicking legitimate services, unsigned or untrusted executables, base 64 encoded command lines. So how they install the malware, they use service installation, right? If they're going to install it from this method, there's other methods to install it, but they use Windows Update. But instead of Windows Update, they put their .exe file in there, right? So that looks like it's just a Windows update, but it's really their malware service, right? Detection indicators, service with suspicious names or descriptions, services pointing to non-standard locations, services with unusual start types, missing or invalid digital signatures, registry key hiding, null byte injection keys with null characters, Unicode, non-printable characters, key name spoofing similar to legitimate keys, subkey nesting, deep hierarchical hiding. They'll use value manipulation, storing strings as binary values, value name spoofing mimicking system values, timestamp manipulation altering last write times, binary encoding, obfuscating string data. They can exfiltrate cookies from your browser by doing browser hijacking, and these registry keys right here are what they would use for browser hijacking. They'd use the HTTP shell open command and HTTPS shell open command, and they would open that Internet Explorer start page so that they can hijack your browser, or they can figure out what one you're using and steal the cookies off of it. Proxy configuration, proxy enable proxy activation flag, proxy server address, proxy override, proxy bypass list. For this, they can make the proxy server the attack server, right? But they're going to have to do better than that. They're going to have to use domain generation algorithm so that they can stay persistent on your computer. Registry analysis tools and techniques, built-in Windows tools registry editor, manual registry browsing and editing, search functionality across keys and values, export-import capability, permissions viewing and modification, regexe, registry command line, reg.exe, common commands, reg. So those are like the commands that you can run in the registry command line. Third-party analysis tools, Registry Explorer by Eric Zimmerman. So this has better like registry hide parsing and analysis, timeline reconstruction, deleted key recovery, hex viewing and data interpretation, plugin architecture for specialized analysis. For Registry Ripper, we have automated registry parsing, plugin-based analysis framework, timeline generation, malware-specific detection rules, batch processing capabilities. For Volatility Framework, we have Hive List Enumerate, Registry Hives, Print Key Display, Registry Keys and Values, Hive Dump Extract Registry Hive Data, Hash Dump Extract Password Hashes, and LSA Dump Extract LSA Secrets. So those are some of the registry plugin commands, right? Hive List, Print Key, Hive Dump, and Hash Dump, and LSA Dump. For PowerShell, registry analysis, basic registry operations, query your registry key, search for specific values, monitor registry changes. For advanced analysis scripts, you have detect suspicious run keys. So you're trying to find the run keys that basically is auto start malware, right? It automatically starts up whenever you start up your computer. Forensic registry analysis methodology, Hive identification and extraction, live system analysis, registry Hive locations. You have your ntuser.dat user Hive, your system Hive, software Hive, security Hive, and SAM for user accounts. And those are where they are at in your Windows drive. So your C drive, Windows System 32, config, and then system. For supporting files, backup, and transaction logs, we have transaction logs, log 1, log 2 files. Then we have our Vista Plus transaction logs. And then we have a registry backup folder, system registry backups. For timeline analysis, we have registry timestamps, last write time, when key was lost, modified, key creation, original key creation times, value modification when specific values changed, access patterns, frequency of modification. We have correlation with other artifacts, file system timestamps, executable creation modification, event log, system and security events, process execution, application startup correlation, network activity, communication timing, malware artifact detection, persistence analysis, detection checklist, run, once key modifications, service installations, scheduled task registrations, browser hijacking attempts, system policy modifications, security software disabling, network configuration changes. For configuration changes, we have Windows Defender exclusions, firewall rule modifications, UAC bypass attempts, proxy configuration changes, certificate store modifications, trust relationship changes. So they'll try and change those to make it so it's harder to detect their malware and stuff like that. Attribution and indicators of compromise extraction, we have mutex names, which are application synchronization objects. So they have to have those objects to be able to synchronize. Service names, installed service identifiers, registry key patterns, specific key naming conventions, configuration values, unique configuration strings, campaign indicators, installation paths, common malware locations, naming patterns, consistent naming scheme, configuration data, C2 server information, version information, malware family versioning. We have detection and rule and signatures with the YARA rules for registry artifacts, suspicious run key detection, this little script right here that tries to detect those suspicious run keys in your run.temp folder, your run public, and your run app data folder. Splunk queries for registry monitoring, new service installation. So this will basically look for the event code 7045 and the certain service name, but it doesn't have the service name. That's just a placeholder, right? And then we have the image path equals public or image path equals app data, table time, computer's name, service names, image path, and account names. For registry modification monitoring, we have index equals Windows, event code equals 4657, object name run, eval registry key, object name, process name, process name. So what this does is it makes sure that nothing in the registry has been modified, especially for event code 4657 and the regedit.exe, so that it can monitor the modifications. We have case study, persistent backdoor installation, initial indicators, new service Windows helper service, discovered service pointing to program data helper.exe, unsigned, executable with suspicious network behavior. Unsigned applications, that's how Windows knows that files might have malware, they might be malicious. If they're not signed by any vendor, or like most open source software would be signed so that you would know, oh, this isn't really going to be malware. But when you install like malicious files, it'll say, oh, you shouldn't run this because it isn't signed, right? Registry analysis findings, we have how you'd find or see where those, the details of it, like automatic start, and then it used it as a service. Then it had its description and display name. So those are the details of what it found. Timeline correlation, service created. It shows when it was created. It showed when it first made a network connection and when the initial compromise email was. Additional artifacts. So those are the initial ones that it found. And it was saying that it wanted to be silent in the background, right? They don't want people knowing that there's malware in the computer. Case study 2, browser hijacking campaign. Initial symptoms, user reports, redirected search results, unexpected homepage changes, pop-up advertisements appearing. So registry modifications discovered. You have the start page as a malicious website, the search page as a malicious website, and the default page URL as a malicious website. For this other one, it is display name enhanced search is also a malicious URL. Favicon URL is the malicious URL icon, right? Persistence mechanism, how they stay persistent. They're trying to auto run it on this line right here. Run dll32.exe, probably DLL injection, right? Best practices for registry security, monitoring and detection, key areas to monitor. High priority registry locations, all run once keys, service installation keys and scheduled task keys, security monitoring policies, network configuration keys. What did I didn't ask. I did not ask Siri anything. So where were we? I did not say Siri once. I don't know why, just started talking. But we were on registry analysis. So let's go back down to, I believe we were right here. Security policy keys, network configuration keys, browser configuration keys, system file association keys. For automated monitoring, we have Windows event log configuration, enable registry auditing, event ID 4657, monitor service installation event ID 7045, track policy changes, event ID 4719, log authentication events, event ID 46244625. Preventive measures, registry permission hardening, restrict write access to critical registry keys, implement least privilege access controls, monitor administrative privilege usage, regular permission auditing, application control, implement application whitelisting, code signing enforcement, restrict execution from temporary directories, monitor unsigned executable execution, response procedures, isolate affected systems, create registry snapshots, analyze suspicious modifications, correlate with other artifacts, remove malicious entries, verify system integrity, monitor for reinfected document, lessons learned, recovery actions, registry restoration process, export current state, remove malicious entries, restore legitimate configurations, verify system functionality, monitor for anomalies, update detection rules, strengthen preventive controls. So we have advanced analysis techniques, memory analysis for registry data, live registry analysis with volatility. They're checking Hive list with this. Volatility for this one, they're printing the key out to see what's on it. Volatility for here, we're checking the system offset and the SAM offset. Network-based registry monitoring. Remote registry access detection. Monitor network connections to port 445. Detect unusual administrative share access. Track remote registry service usage. Analyze authentication patterns. For machine learning, we have registry key naming pattern analysis, unusual modification timing detection, behavioral baseline deviation alerts, threat intelligence integration, compliance and documentation evidence handling, chain of custody requirements, timestamp all registry modifications, document analysis procedures, maintain integrity hashes, preserve original evidence, create detailed analysis reports, legal considerations, privacy protection requirements, data retention policies, disclosure obligations, cross-jurisdictional issues, expert testimony preparation. Reporting standards, executive summary, analysis methodology, key findings, time out of events, indicator of compromise summary, recommendations, and appendices, raw data. Summary and takeaways, comprehensive monitoring, monitor all critical registry locations continuously, baseline knowledge, understand normal registry configurations and changes, rapid detection, implement automated detection for suspicious modifications, thorough analysis, correlate registry evidence with other systems, artifacts, effective response, have procedures ready for registry-based incidents. Key reminders, registry changes often indicate persistence, focus on startup and service locations, timestamps are crucial, always consider timing in your analysis, context matters, correlate with other evidence sources, backup before modification, always preserve original evidence, document everything, maintain detailed analysis records, emerging trends, living off the land techniques, abuse of legitimate registry features, fileless malware persistence, registry-only persistence mechanisms, PowerShell-based modification scripted registry manipulation, cloud-aware threats, registry modifications for cloud service abuse. Some additional resources, we have those tools, right? But that is going to be it for registry analysis. Thank you everybody for watching.